We are live. Welcome everyone to this week's change notice. This is an exciting one. We've got our X-ray partner, Creative Electron, joining us. So as you guys file in here, we're going to wait a few minutes for everyone to file in, but please introduce yourself down in the chat in the lower right. Very important note though, you'll have to change the little blue box. Instead of hosts and panelists, change that to everyone. Otherwise, you're just going to be texting us the whole time. I still don't know why Zoom hasn't taken my feedback to make everyone by default. But please change that to everyone and introduce where you're calling in from. And we'd also love to hear, what is your first experience ever with X-ray? First experience. So while we wait here, David, you want to share your first X-ray experience?
Yeah, I mean, as a kid, I'm sure I got some dental X-rays or something like that, but I don't remember any of those. I'm fortunate enough to have not broken any bones, so I didn't have to go for any of those kind of X-rays. But definitely the most memorable one was my firstborn son. 1 week in, he had a fever, and so we had to go to the hospital, and they did all these tests, and he's fine. But one of the tests was to introduce some barium sulfate into his body to make sure that fluids were traveling in the right direction. And so we went in this big room, and I'm holding my 1 week old child on a table, and I get all the lead apron and stuff like that on, and it's pretty neat. I mean, obviously there's the little bit scary side, but from the geek in me was enjoying the X-rays and what you could see and the live movement of different things. So it was pretty awesome what that could do to diagnose a condition. In this case, there fortunately wasn't one, but able to exclude that with the use of X-ray. It's pretty awesome.
Yeah, that's a memorable example. I'm glad it turned out well. For those of you just joining us now, we're sharing our first ever experience with X-rays. So please introduce yourself in the chat in the lower right. Make sure you're sending it to everyone and tell us about your first X-ray experience. Thinking back, mine was also medical related, not quite that early on. But the most memorable is I broke my ankle growing up, and I distinctly remember when the doctor came back with the X-rays, both of the broken ankle and after I got some screws in the ankle, the side by side.
Oh wow!
And I remember being so fascinated by it that we went to some extra effort for them to go photocopy them, so I could take some copies of the X-rays home. I just thought it was so cool, and I wanted maybe not I wanted a memory of it to hang on my wall, but I thought the technology was cool, and it's fascinated me ever since. All right, so we're gonna play a little fun game here while we wait for a few more people to file in. We're gonna guess that X-ray. So we've got a bunch of sample X-rays that David and the Creative Electron team have taken for us. We're gonna look at them in the instrumental application here, and I want everyone here in the chat. We're gonna see who can guess the device first as I slowly zoom out here. So this is number one. I'm gonna move around. Looks like we've got maybe a motor here, a battery. I've got one guess for controller, not quite, and Leo comes in for the win. There it is, massage gun. We got the Theragun here. All right, that's 1 point for Leo, for anyone keeping score. Leo, you're just texting us, just a heads up. We will count your answer, but you got to change it to sending to everyone to make sure everyone else knows that you were first. Let's do a couple more here. I like this one here. This is a pretty cool X-ray. So it looks like maybe a fan, some cables. I see notebook, laptop, think a little bit bigger, MacBook. I see the stand here. All right, we got it. Jeremy got it with the MacBook, the iMac.
Yeah, that one actually took like 8 different shots, I think, to get that one on. That was a big one, 26-inch, I think, the size of it.
This is a very high resolution X-ray. It's pretty fun just to look at all the intricacies inside here. All right, let's do one more. Let's do one more, see what we can get. Zoom way in. I'm gonna make this one hard. All right. That might give it away there.
No one yet?
No one. Looks like a little connector down on the bottom. Main PCB. One Andrea voting for speaker. Ear pods. There it is. Ear pods. More specifically, AirPods. But yes, Leo got it again. All right. Awesome. Well, we can come back. I could do this all day. We'll come back to this more later at the end if you guys want to stick around. But let's officially kick this off. So welcome everyone to Change Notice. I'm joined here today by David. Change Notice is our weekly video podcast where we talk about all things electronics, supply chain, manufacturing, and it's hosted by experienced mechanical engineers, design engineers, and the goal here is we really want to build a community for knowledge sharing, support, and continuous improvement. And today's special edition, we're joined by our partner, Creative Electron. Excited to have David on board here. We're going to talk about X-rays and electronics. And before we dive in, for those of you just joining us now, please go ahead and introduce yourself down in the chat in the lower right and share what your first experience with X-rays was. Could be growing up, or it could be first professional experience. And throughout the presentation, we encourage you just ask any questions throughout, and we'll either address them live or we'll get to them towards the end. All right, let's dive into it. So just a quick overview of what we're going to cover today. We're going to go through who we are. We're going to talk about all the different applications for X-rays, why people use X-rays. And then we're going to hone in on just X-rays in the electronics industry. We're going to talk about the status quo, how they're used today, and then some of the opportunity that we're working with Creative Electron on, some of their unique solutions. And we're going to talk about how remote X-ray analysis can actually help to solve even more problems. And then we've got some great customer use cases, both from Creative Electron and from Instrumental, on how they've used this solution. And plenty of time for questions at the end. All right. So I'm Tobias. My background's in mechanical engineering, product design. I did product design at Apple for about 6 years, working on Apple Watch, iPhone, specifically on sensors, health sensors, touch sensors. And now I'm at Instrumental leading our solutions architecture team. And excited to be joined here by David. David, do you want to say hi?
Hi, thanks for having me, Tobias. It's pretty awesome. Just a brief introduction. I'm currently VP of Sales at Creative Electron. Background, I have an electrical engineering degree, and I've been in the electronics manufacturing industry for about 10 years now. So, been with Creative Electron for about 3.5 years. What really drew me to this business and just X-rays in general is it's fun. You get to look inside of things. See how things work internally without having the messy part of taking it apart and having to put it back together. So we call that non-destructive testing. As a kid, maybe you like to take things apart, right? But the little kid wants to put all the screws back in the right spot. So with X-ray, we can just look inside of stuff. So it's always awesome. There's always something new to look at. it's a lot of fun.
Great. Well, we're excited to have you here. So before we go to the next slide here, first want to hear from the audience. When you hear X-ray, what is the first application you think of? When you hear it out of context, what do you think of when you hear X-ray? So go ahead and post it. I'm curious all the different applications. I've got my bias. We've got dentist. That's a common one. Let's go to the next slide here. So dentist or medical is the first ones that David and I shared, but there is a huge variety of applications here. Andrea, airport, that's another great one. So medical is a huge one. Baggage screening, going through the airport. Dental, again, I personally I'm not a huge fan of the little receivers that they stick inside your mouth at the dentists. Veterinary, border checks, huge variety. Really today, we're focusing in on what we have in the lower left here, PCB inspection, electronics, X-ray inspection. So that's where we're gonna focus. David, I'm curious, from talking with all the customers that you guys meet with, what's the most common initial conception of X-ray?
A lot of people are think of the doctor medical field, broken bones, that kind of stuff. So we've actually dealt with several different customers who they use that same technology. We've actually still encountered in the last few years people who are using film, which is just a very painful way to take X-rays. Like a minute exposure time, and then you got to take the film over and you got to process it and deal with all these chemicals and all those kinds of things. So taking them from that to modern X-ray technology with automation and things like that is just it blows their mind. It just when you go from old technology to current technology, the image quality is just staggering. And a special note to Josh here. I love his first experience with X-rays, NDT of carbon parts. It's a unique life, right? Most of us experience it a little bit earlier. But yeah, non-destructive testing on carbon parts. That's where you started. Good for you.
All right, let's jump into electronics. So I'm going to share a little bit about the most common use cases that I've experienced. This is from my 6 years at Apple in the electronics industry. So the first bucket here, if you want to advance one slide, first bucket here, PCB inspection, solder inspection. This is a common one, looking at solder voids, bridging, wetting, anything SMT related, maybe trace cracks, and a couple different setups. Sometimes this is 100% inline inspection. More often it's sampling quality checks that are being performed here. And this is great for what it is, but the limitations here, you're really looking at very specific targeted areas. You're just looking at this component, just looking for this defect. And even once you're collecting these X-rays, it's pretty hard to actually access them. Very rarely do people actually do additional analysis on these X-rays. Normally, they just kind of sit on the machine and you probably never see them again. So limited use case here. The next bucket, and the one that I actually have the most of experience with, is failure analysis. So a lot of you guys know reliability testing, a very critical part of developing a new product. You can see here some of the example tests, drop tests, environmental tests. And when a device fails, one of the first FA steps that we would do is let's CT scan it. I just want a snapshot. I want to know what's going on inside, because if you open up the device, you often damage some of the evidence. So CT scan is the best way, but the limitations here, these CT scan machines, these are huge, expensive machines. We had one machine in the lab, so you'd have to request CT test. You have to get in line, and it might take a couple days before they actually get around to doing it. So it's great when you can do it, but it's really only onesie, twosie failures, and you're only reacting to a few failures. You're not doing high quantities here. And the third one here, and this is really where the opportunity is, almost the holy grail of doing 100% assembly inspection. This is either because there's a blind assembly where there's no other way to inspect it, or you want to just add on an additional quality check to look for part presence, absence, alignment, just get that extra data. And the reason that this isn't actually that common is it's actually pretty difficult from my experience working to find a reasonably sized solution. The conception that David was talking about was, you get kind of low quality x-rays. These are giant machines. Like, this isn't something that I would put 100% on my assembly line. So the result is not actually used that often. I'm curious, David, from talking with your customers, what is the most common use case that they've had to date?
Well, at Creative Electron, we deal with all three of these pretty regularly. PCB stuff, there's always people looking at those bottom terminating components, right? You got solder joints that are happening out of reach visibly, so you got to x-ray those. We do CT. A lot of times people come to us and say they want CT, and then if they've had experience with it like you, realize it's not super user friendly. It's not that convenient, and maybe I can do what I want to do with just a 2D x-ray. So we have a lot of failure analysis labs in situations like yours where they say, hey, you've got to go to the building next door to access this big CT machine. You got a benchtop 2D system that we can just have here. Maybe I share with the lab mates on my floor or something like that. And it's just, so much easier. But we're seeing a lot of growth with this assembly inspection as people realize that it's not $500,000 to put an x-ray machine in their line that can look at some blind assemblies and find out that, yeah, this is great, right? We can root out a lot of problems by x-raying the final assembly after it's all fully put together and cameras can't get at it anymore. We're seeing a lot of growth in that area.
And that's actually, if we hop to the next slide here, that's actually the exact problem that Puffco approached us with. So right. A little setup on the problem here. One of our joint partners here that approached us, Puffco is one of the leading makers of consumer vaping devices. And they had a new product that they're developing, has a complex blind assembly where there's this critical component being assembled inside of an enclosure. And they needed an x-ray to actually see inside. And they wanted a small desktop form factor, high resolution, 100% inline, and they didn't know if it was possible. And on top of that, they're building these devices over in Asia, and the engineering teams here in California. They wanted to be able to do remote failure analysis with these x-rays. They wanted easy access, and they didn't actually know what defects they wanted to program for. They knew there was going to be some number of different anomalies, but they weren't quite sure what it was yet. So they needed an AI-powered system to actually find these new issues. And so this is the problem that we teamed up with Creative Electron to tackle in two parts here. And so for the first part on the x-ray solution, I'll hand it over to David to tell us a little bit about their unique solution.
Yeah, go to the next slide.
Yeah, if you want to go to the next one. And I'm also curious from the audience here, when you think about x-ray machines, what is the size? If you had to estimate the size of an x-ray machine, go ahead and post it in the chat, kind of what the average size is that you see, or what the smallest sized x-ray machine that you've seen in the past.
Yeah, so quick introduction to Creative Electron. We were founded in 2008 and acquired one of our competitors in 2016 to become the largest U.S. manufacturer of X-ray systems for industrial use. We make all of our stuff here in Southern California. We're in the northern part of San Diego County. And so our manufacturing team is here. They're downstairs. Software team is here behind the wall behind me. We're doing everything here. So we make standard machines and we customize them. We do a lot of customization or a little customization, and it really just depends on the need. So here with Puffco, they came to us and said, hey, we have an assembly line. We want to X-ray something. I don't have, 5 feet by 5 feet to put something here, right? I need it small. Okay, we've got our TrueView Cube, right? This is a 16-inch by 16-inch footprint, pretty small, nice and compact. Their device fits easily inside there. They didn't need a really high-end, beautiful, high magnification, crisp image to do their analysis. And so we're able to put a image train in there that gets them the image quality they need. And so we're meeting them at a price point that they want to pay to get what they need, rather than, oh, hey, all we have is this TrueView Fusion size thing, and it's going to cost you $500,000. That's not how we work. So the Prime is also a benchtop system. It's about 31 inches by 31 inches. So again, pretty compact. The Fusion is 3 feet deep, 4 feet wide. So again, we're trying to make things that are accessible, usable, fit through a door. So you don't have to take the walls out in order to remove your X-ray machine and install it. So it was a perfect fit for Puffco for sure.
Yeah, and we're seeing kind of similar initial feedback here from the audience. Leo and James, the most common machine sounds like 5 foot by 5 foot, around the size of the Fusion, kind of these larger machines.
Right.
And yeah, really the unique solution that drew us to work with you guys was this small, approachable desktop cube. That's just really unique, and something that I wasn't even aware before we started working together was an option here. All right, let's talk about some of the use cases. Oh, actually, no, you're going to teach us about X-rays first.
Yeah, just a quick basic introduction on X-ray. We have the source here on the top, and so this. Let me get my arrow here. So the source here on the top, this is generating the X-rays. It's creating the photons, the light, invisible to us, but it is a light. And it's sending those down in this cone beam. And then there's a camera on the bottom, or a sensor. And most people expect that as you bring a camera closer to something, you're going to get more magnification. But actually, as the sample goes down, you'll see on the animation on the right, the magnification decreases. And that's because with X-rays, you're dealing with shadows. They used to be called shadowgrams. And so you have this light source, and it's making a shadow, and you're just looking at that shadow with your camera. And so it's kind of counterintuitive when you're using some of these machines sometimes, because we're used to optical cameras. But you're able to get that shadow, and the darker, in our case, this opposite of medical stuff, the darker the image is, the less energy the X-ray photon had when it hit the detector. So that's what we're looking at. There's 65,000 shades of gray in these sensors. So they can detect a huge variance in level. And that's just so much information that we need AI, we need computers to handle that for us, because our eyes can't detect that many shades of gray. And actually our monitors can't even show it. So.
And David, I know a lot of people assume that there's this safety issue around X-rays. You're at the dentist and they put this giant lead blanket over you. How do you guys handle that in your machines?
Yeah, so the FDA regulates X-ray, of course, because it is a safety concern. In our case, they classify it as a cabinet. So basically the expectation is that radiation will not exit the cabinet. And so that is our responsibility as a manufacturer. And we're always testing for that. When we build something, we test it, we ship it to the customer, we test it when it arrives, make sure that the radiation levels outside of that cabinet are not affected by the cabinet itself. So they're very safe to use. You don't need lead aprons. You don't even need dosimeters to monitor your radiation levels if you're working with a cabinet system like we make. Yeah, so they're very safe. It's shouldn't be a concern for operators.
Great. Well, let's talk about some use cases.
Yeah, so this is a case where a customer came to us with some batteries to inspect. These are examples. Bought these on Amazon. They're rechargeable lithium-ion batteries. So I just thought this was really cool. Over on the left side here, you have this PCB inside of the head of a AA battery. This must be for controlling the recharging of them, and whatnot. But I just included it here because I thought it was pretty awesome. The kind of technology we're cramming into a tiny little space, and a consumer battery that's not expensive. Pretty cool stuff. There are some little dots you might be able to see here. And that looks like FOD to me, foreign object debris. I don't know exactly what it might be, but I wouldn't be happy about that if I was a manufacturer to see that kind of thing inside of my device. You don't want things rolling around, especially inside of batteries. So here on the right side, we have two different cells. These are jelly rolled. So what that means is you take a really long sheet of a layer of anode, cathode, and insulator, and those three layers are just laid out and then rolled up like a jelly roll cake. So what you're seeing here on the bottom is this is the insulative layer that's sticking out beyond the cathode anode layer, separating those layers so you only have one layer of reaction going on. So this is good. On the top one, you can make out that the cathode anode layer is actually sticking out just a little bit beyond that insulator. So in theory, these could touch and short and cause a problem, a big problem. As I'm sure everyone remembers with Samsung a couple years back, exploding batteries. Well, once these chemical reactions start happening, once there's too much heat, you cannot stop it. You can't put it out with a fire extinguisher or water or anything. So that was a huge problem for Samsung back then, which has really helped with awareness of inspecting batteries, especially lithium ion. But it also means, you and I can't pack lithium ion batteries in our luggage on a plane, right? You can't check it in anymore. I want you to be carrying it on your person. Not sure how that helps, but at least I guess you can control it, not the whole cargo hold on fire. But to me, this is an issue here. These sticking out, again, from a manufacturing perspective, I wouldn't want those to be shipping. But I'm not a battery expert. I just have some experience from talking with customers. So maybe this is acceptable. But either way, it's something to be aware of. And you're only going to see that with the X-ray.
Yeah, this is a great use case. I know a lot of the customers that we work with are very focused on battery quality because the severity of the failure is so high. And X-ray is a great tool. There's a lot of other just visual inspection. Again, would love to hear from everyone in the audience here. Besides X-ray, what other quality control tools do you guys use for batteries? Do you do sampling of X-rays, just visual inspection? I know there's a lot of focus that goes around batteries. Let's go on to the next use case here.
So cell phones, we all love them. This is actually two different cases, but it can also happen within one facility. But the left side here is a matter of refurbishment. People are taking old iPhones, and they ship them out to a facility that just takes them apart, put together, refurbished, and ships them out. And you can see here with this little red square, there's a screw. So that's just it's on its side. It found its way into a little hole there, and who knows what's going to happen to that? Again, foreign object loose inside of a phone, it's going to short something. Not something you want to be exiting the facility for sure. RMAs are never a good thing. So that was caught with X-ray. They X-ray every single phone that goes out. A lot of times what they find is actually just screws missing. So these dark circles are screws that, a lot of times someone would forget to put in. So in this case, you can see them there, but in a lot of the images that we saw back from the customer, just operator forgot to put in a screw. On the right side here is something a little bit more interesting, more intriguing. This is cell phone returns, fraud involved in that. So on the upper left, we have an authentic iPhone. That's what it looks like under X-ray. It's here. Over on the upper right, we have one of those phones. I don't know if you go into like Target or Walmart and you pick up a phone, and it's just a dummy phone, but it kind of has the weight of a phone, right? And you look at it and you can tell it's pretty fake. But at least it gives you the feel of the size and the weight that you're going to be purchasing. Well, if you were to go to T-Mobile store when the latest iPhone comes out, and you say, "Oh yeah, I want to trade in my phone," they're offering to give you the latest phone in exchange for yours. If you were to hand them one of these, depending on who's there, they may not care less that this is a fake phone you're handing. Kind of feels right, good enough. Hey, it doesn't turn on. Oh yeah, don't worry about it, right? It doesn't have charge, or okay, cool. So they take it. They're not going to find out until it gets back to the central facility. Someone opens the box, looks at it, says, "Oh, it doesn't turn on." They plug it in, right? All this time and labor that goes into it. Well, if at that facility you use X-ray as the box comes in, you can X-ray the box itself and see that's fake, that's junk, and just trash it. Don't waste any more time on it. Tracking with barcodes is super easy. So a little bit more authentic here in the lower left. This is what's called a Go phone. Again, you can buy these pretty easily. Looks a lot more realistic than this upper right one does. And you can turn it on. It loads a iOS looking operating system, and it'll get past a few more tests before it gets caught. But again, it's from the company's perspective, it's a waste of their time. So X-ray is able to root those things out really quick, save them a lot of time in processing. So this isn't failure analysis, right? This isn't solder joint quality. This is just, I don't want to open 500 boxes a day. Let's see what's inside of it at a quality level that's high enough to determine between that Go phone and the real iPhone on there.
Yeah, this is a unique use case here.
Yeah.
But even I like seeing, even with it, even though you're looking for just gross differences, you still actually have a pretty good level of detail. And my PD mind is kind of looking at all these small little components here, the little springs and the home button and the haptic engine.
The speaker jack right there in the lower right.
And hopping to other applications in kind of this cell phone X-ray, but we'll look at some of those later as well. Let's hop to the next one here.
Yeah, so electronics, like we said, is very common. People are X-raying electronics. It's just a matter of do you as the engineer ever get to see them? But this is a BGA over on the left side. By far the most common component that gets X-rayed. And this is one that we did some rework on. It's intentionally horrible. It's got shorts in it. It's got opens in it. It's got, stretched, lifted solder joints over there. These look like they're not even touching. So you have issues all over the place. Solder balls, solder splatter, all sorts of problems. We just introduced it so you can see it. But this is all happening underneath the component. You can't tell what's going on until you X-ray it. We're able to get right through the plastic layer on top and just look at those solder joints, what's going on. And over on the right side, if you're in failure analysis and trying to figure out why this thing isn't turning on or something's not working right, well, in this case, hopefully you all can see it, but there's some breaks in these bond wires. So obviously the signal is not going to get from this lead over to the die because it's broken. The connection's just broken. So, and that's all happening inside of that protected area. You can't see it with the camera. You might know that the device is dead, but next question is, why is it dead? You find out it's those bond wires, then you can start doing, okay, what kind of electrical overstress did this see to have that happen, right? Continue with your FA after that.
Right. Yeah, that's a very minuscule failure there. That would be pretty hard to catch without these X-rays.
Yeah, but catastrophic, right? It just doesn't work. You're going to be looking all over if you really want to figure that out until you just X-ray it. Say, hey, broken bond wire.
So let's. I would love to hear again from the audience. This is the electronics use case is very common. I know some of you guys have probably experienced this electronics use case. I want to know, how would you today, if you wanted to take a look at, let's say, the last 100 units that got X-rayed to look for these bond wires, how would you go about getting those X-rays? Like, do you have easy access to those? Who would you have to talk to get that? I'm curious the different systems that everyone has set up. So let's talk about how we solved this Puffco use case. Combination between Creative Electron and instrumental. So we talked about they wanted this fast, inline, approachable X-ray system and failure analysis remotely in the cloud. So David and team customized the small cube. This is just the 16 by 16. And it's now running 100% inline. And there's actually a rotation fixture inside. So we're getting two different angles of X-rays. And then those X-rays are automatically being piped into Instrumental's cloud system so that their whole engineering team here in California can easily access all the X-rays, do their failure analysis. And we actually have AI that's running on all of these X-rays, automatically pointing out new anomalies for them. So this is really the best of both worlds. They're getting that inline X-ray analysis, as well as all this additional AI analysis that's being done in the cloud. And the best part of this was actually how quickly we were able to prove out and get this solution up and running. David, I remember when we first were talking with Puffco, I think it was just a couple hours, maybe one day, where we took some sample X-rays, uploaded them into our app, and proved out this full solution.
Yeah, it was really quick. One of your colleagues brought in some samples from Puffco and able just X-ray them and determine really quickly what the problem was and what we needed to do in order to get them a solution to be able to, prove that X-ray was going to work and the quality of image that they were going to need. It was very quick.
Yeah. So this was a great use case, and I'm actually curious. Again, as we go through the rest here, I want to hear about other use cases from the audience. So think about, you can post them in the chat if you've got questions on use cases for David. Would the capability work for your application? We definitely want to get to those questions there. And what's exciting, if we go to the next slide here, beyond just this one X-ray, how this fits into the broader instrumental system. So just a refresher for those not familiar, the instrumental platform, we aggregate product data. This is functional test data from your entire assembly line, along with images during your assembly. And we aggregate all of that into our cloud database, so it's all centralized. And what we're adding on now, if we go one more slide forward, we're adding on X-ray as an additional data source to our platform here. And what this enables, this is a very data-rich source. There's a lot of valuable data in this X-ray. And when it's connected with the instrumental system, we can actually automate correlations between that X-ray image and the other data on your line. So you've got all of this data in one spot. The first things that come to my mind is, let's say, variations in placements of PCBs that could be tied with antenna tests, other audio tests. And these type of correlations would be nearly impossible to draw without having all that data in one centralized system. like instrumental. So that's what I'm really excited about, is getting more value from that X-ray by connecting it to the rest of your data. And then once you have all this data in the instrumental platform, again, really the goal is for your entire team to be able to use the insights and to be able to get value from the X-rays. I see some answers in the audience on how do they access the X-rays. Yeah, most people don't have easy access. Some vendors provide some ad hoc software. You can send over the X-rays. Really, instrumental centralizes all that. You can make dashboards from it. The product design teams will be able to use it for FA. Quality teams will be able to monitor over time. And we're also doing that real time in line. So making data accessible to the right people in real time. That's what we're enabling here.
Yeah, and a lot of your vendors, as Andrea mentions there, a lot of the vendors have X-ray somewhere in the facility. They'll be able to get to them. They'll use them internally. Usually they don't want you to even see the X-ray, right? They just want to ship you the product. You got to pay extra for that. But in the case here, we're providing, Creative Electron provides an X-ray machine that takes the pictures and is automatically sending those pictures to Instrumental's platform. So it's fully automated, seamless, and then your whole team can take a look at them. So you don't have to worry about someone trying to not take pictures or only send you the good ones, things like that. It's all automated and happening without someone on that end, having to push an extra button to send it over.
Exactly. And I think it would actually be great to show a little demo of, David, of your X-rays in the instrumental platform, just to give someone a sense for how easy it is to flip through. So I'm actually going to show the instrumental platform here. And again, for those not familiar, I've got all my serial numbers over here on the right. This is an example device, super easy to navigate around. But what I find really insightful, just flipping through the X-rays. So again, this device likely being produced overseas or maybe at a different facility here in the US. Even just flipping through, I can see all sorts of variation. This is even before the AI starts working. And then the AI is going to automatically process and start highlighting potential anomalies for me to jump into failure analysis on, do some correlations, and really just resolve those issues sooner. But it's just a great way to visualize that final assembly of your product. And there's just so many insights that you can get that aren't currently being leveraged because we don't have easy access to this data. And what we can actually do for any of those interested in trying this out, we similar to what we did with Puffco, Instrumental has this image POC. So if you have X-rays, if you have existing images, let us know, and we can actually set up a little free POC to put your X-rays or images in the app and do a little quick demo. It's actually super easy to do. We can do it in just a day. And it's always fun to see everyone's different applications. So let's pause there for questions from the audience. I'm curious what other applications. I like to hear about new applications that people have. So any questions on can Creative Electron's technology help us with this? Anything on the collaboration with Instrumental? Please go ahead and post it down in the chat. And I think you can actually also raise your hand to actually come up and talk with us live here too. Looks like one question to start us off. What is the most unique X-ray application that you've seen? David, you wanna take that one?
Yeah, we've X-rayed all sorts of stuff. We just did a bowling ball for Veritasium recently. That was pretty cool. I never really thought about X-raying a bowling ball. And there's this inside of it. the weight is actually offset. I'm sure for people who know about bowling, this is no surprise, but I thought it would just be, try to be very centered and everything, but they offset the weight for a certain spin. You can watch their whole video on it. It's pretty awesome, but that one was a little bit surprising. I'd say the most surprising one is X-Ray handbags, high-end fashion, Louis Vuitton, I don't know, Chanel, I don't know the other names, but that I am familiar with X-ray handbags for the sake of looking for guns and stuff inside of it, right? Security checkpoints that we all know about, but had a customer who is authenticating handbags, make sure that they're the real deal and not a knockoff. And so X-raying and looking beyond the outer layer turned out to be huge. Big difference for them.
That's really interesting. Handbags would not have been the first thing that I would have guessed.
Exactly.
All right, a few more questions. Keep the questions coming in. You can either type it in the Q&A, the chat, or raise your hand to come up here. Looks like a question from Leo. Do you have video X-ray capabilities, high-speed X-ray?
Yeah, we do videos. Some of our machines are just still shots. Some of them get a pretty quick. Digital flat panels, you're going to get maybe 100 frames per second, but we can do, with using an image intensifier, you can get a lot faster, and there's really high-speed ones. I think exists out there, you can get up to like 1,000 frames per second. So you're not going to be at quite the level of a really high-speed optical camera that you get to see, but that's quite a bit of speed if you need it. So yeah, let us know if you have an application that you want to check out with that.
Yeah, video X-ray. That's a very interesting. I know you guys have like CT to do 3D, but I'm assuming Leo, you're asking about. I actually remember back at Apple, towards the later years, we invested in what I think is what you're referring to, a high-speed video X-ray, where you could X-ray while you drop a device, and you could actually see. This was like a crazy expensive machine. Yeah, see, Leo knows what I'm talking about. While you drop the device, and you could actually see as it impacts. I think it was some crazy high frame rate. As it impacts, you can see all of the internals actually shift around, which was just crazy to see. And we use that to feed back into a lot of the FEA simulations, that you make a lot of assumption about what moves around inside, but this actually validated some of that. Let's see, another, keep any questions on applications. Let's see. Oh, Jeremy had a question on example data sets of 3D CT scans available. What formats do they come in? David, if you want to talk formats, I do actually have some examples from your website here on, these are some of the post-process, I would say, animated CT scans, but they're very visually appealing, I would say, looking at these.
These are actually, it's a GIF. It's just an animation of, we're rotating that sample around. It's what you would do right before you do the reconstruction on CT. So CT, you have to either rotate the sample full 360, or you rotate the source and detector around the sample, depending on the application. The formats for those, DICOM is very common, but you can also get it exported as like an STL file. There's a couple other different formats that are pretty easy to use that you can pull up. Actually, I think even just Windows, the native Paint, can open some of those files now, the skin files at least. But yeah, these ones here is just a rotation of, it's just a compilation or a stack of 2D images that we put into an animation for you, because the level of detail here is pretty awesome. You lose a little bit of that sometimes when you're doing the reconstruction, but there's as far as compiling, a whole run of a product, their CT files becomes a little bit more cumbersome. Those are huge files, but CT can be done very, very quickly. You can do 30-second CT and reconstructions of samples. Your level of detail is going to be down quite a bit more. If you wanted to do, like Tobias was talking about, a whole cell phone down to the level of detail of the solder joints, you're going to need a big machine and run for a while to get that level of detail. There's a whole bunch of variants with CT as well.
All right, great questions. Thank you, Jeremy. Few more coming in. We've got a few more minutes here, so please post any questions either on applications, technology. Now's the time to ask. We've got one on what other data types can Instrumental take in, and that's a great question, because X-ray again is a new thing for us. We're super excited about the potential, and again I'll show you here where this fits in the app. So the X-ray again is just another really valuable data source. The other most common ones, just optical images. So we've got high resolution cameras that we can deploy, or we can take in optical images from your AOIs, from your Keyence, from your Cognex. And then we also take in functional test data. So this is often from end of line testers. Sometimes we'll do measurements from any type of measurement device that you have on the line. And one thing that we're also releasing is any type of 3D data. So height data, kind of in a similar vein to X-ray, of just getting more data. If you have height data, can be converted into a color map. We can also take that into our system.
Nice.
Yeah. All right. I think we're just about at time here. So a few reminders, but when you head out here, there is a survey and we'd love to get your feedback. So please, when you exit out of the Zoom, fill out that survey. And next week, actually next Thursday, I think same time, we're doing a live teardown of the DJI mini drone. So those are always really fun. So come back and tune in then. We might even have an X-ray from David and the Creative Electron people. All right, so let's wrap up there. This was a lot of fun. Thank you to David and the Creative Electron team for the ongoing collaboration and for joining us here today. And thank you all for joining, and thank you for all the great questions. We'll see you next time on the next Change Notice.
Manufacturing is changing, and keeping programs agile and on schedule is harder than ever. Leading engineering teams rely on Instrumental to find issues earlier, fix them faster, and make sure they don't come back. Experience the first manufacturing optimization platform designed to enable continuous improvement of your process, from development through production, by unifying your data so your teams can make decisions faster. Instrumental makes finding correlations in product data easy, so your engineers can spend less time wrangling data across email, spreadsheets, and internal systems, and more time solving problems. It's simple. We put the right data in front of the right people in real time. Instrumental aggregates images of every unit at key assembly stages, parametric test data, and measurements in real time in a secure, managed cloud. When installed across factories in a supply chain, brands and suppliers are able to work together to solve their most complex issues. From your first build, Instrumental's Discover AI proactively identifies new issues by scanning your products for anomalies and automatically delivering a daily queue of issues. Engineers can jumpstart failure analysis with defects in context. Engineers leverage a rich, remote dataset to quickly identify correlations and potential root causes, and can push live tests to validate solutions immediately. They use Instrumental to eliminate issues at the source and make sure they don't come back. With complete build and issue analytics for the entire team, program leads can kickstart daily stand-ups, streamline executive reporting, and communicate seamlessly with global teams. Instrumental has helped leading engineering and operations teams move faster, improve yield, and build better products from proto through production. Better products start with better data. Better products start with Instrumental. Schedule a demo today.